Hello, in today's video, we're going to cover the IXL assignment, solve equations involving like terms with that shortcut code Q2B. When you're solving equations, especially when you get into larger ones that have multiple steps and require you to simplify before you are actually able to solve for your variable, it can get a little complicated on knowing what to do first. So if it helps you, you guys could use the mnemonic, "Don't call me after midnight," to help you remember the steps in which you can solve an equation. All right, so here's what "Don't call me after midnight" stands for. If we look on the left here, it stands for distribute, combine like terms, move the variable, add or subtract, and then multiply or divide. So we are going to use that to help us out here today. So if it helps you, cool beans. If not, if you're able to know the steps without using it, that's totally fine. All right. So if we look at our first equation here, we are being asked to solve for h. So first, I'm going to rewrite it off to the side so I actually have room to do my work. We have 9h minus 8h equals 7. I encourage you guys to all do the same. Have a little piece of paper next to you, or maybe like a writing tablet, so that way you can write the equation down and show all of your work. Because even if you're able to do some of it in your head, when it gets to larger problems, you'll need to show some steps. So by practicing that now, it will help you when the equations get more complex. All right, if we use that mnemonic, "Don't call me after midnight," the first thing we're looking for is to see if we need to distribute anything. Well, I don't need to distribute anything because I don't see any parentheses, so we can just cross that off our list. Next is combining any like terms. Well, before I go and combine like terms, I'm going to draw a line through my equal sign. Because when we're combining like terms, we're focusing only on one side of the equation. So you want to know if there's any like terms within the expression, because an equation is two expressions set equal to each other. So first, I'm going to look at the left side of my equation. That is the 9h minus the 8h. Do I have a like term there? Yeah, I do. That's all I have, actually. The 9h and the 8h are like terms. Since I'm staying on the same side of my equation, I'm not crossing over, I'm just simply combining the like terms. I just do that. I combine like terms. I do what it says. So what would be 9h minus 8h? Well, it would be 1h, which means I can simply just write an h. All right, let's look at the right. Do I need to combine any like terms on the right side? Well, no, I only have a 7. There's nothing to combine it with. So I just write a 7. All right, that step's done. Wait, that happened to solve my equation. I don't need to do any of the other steps because I already know what h is. All right, sweet. H is equal to 7. If you wanted to go back and check your work, you could substitute, you could plug that 7 in for h, solve, and then you would get a true statement. All right, let's try this one. Solve for j. 19j minus 18j equals 12. All right, once again, if you want to use the mnemonic to help you out, you can, or you may not need the mnemonic until you get to larger problems. It really just depends on how your brain works, and everybody's works differently. All right, I'm going to use it though. So first step is to distribute. Do I have anything to distribute? Nope, don't see any parentheses. So don't need to do that step again. Oh, but before I get to checking about combining like terms, I'm going to split the side because that just helps me visually see, okay, I'm either looking on the left side of my line or I'm looking at the right side of my line. Do I have any like terms to combine? We do again. We have 19j minus 18j. Those are like terms because they have the same variable with the same power. They both have a j. So let's go ahead and do it. What's 19j minus 18j? just a 1j. So we're left with a single j again. Do I have any like terms on the right side? Nope, it's just a 12, so bring it on down. And oh, look at that. Once again, we're done already because j is isolated, j is by itself. We know that it represents 12. All right, let's step it up a notch here. Ooh, this is a good one. We are going to solve for Q. Let's rewrite our problem again. 16Q plus 2Q minus 13Q equals 15. And I'm going to go ahead and just start off with drawing that line through my equal sign. Not a very good line. That's okay. Such is life. All right, first step. Do we need to distribute? Nope, no distributive property. All right, how about combining like terms? Yeah, in this case, I have a lot. I have a 16Q, a 2Q, and a minus 13Q. All three of those are Q's, which means they're all like terms. I'm just going to work from left to right. So first, let's combine these. 16Q plus 2Q is 18Q. We have 18Q minus 13Q equals 15. But then I still have two more like terms. 18Q minus 13Q would be 5Q. So we're left with 5Q equals 15. Any more like terms? Nope. All right, so that step is donezo. Let's move on to the next, move the variable. Nope, there's no need to move the variable because I don't have multiple variable terms. The only time we would do that is if we had a variable term on both sides of the equation, then when we need to move them so they can be together. So that's a no. All right, how about adding or subtracting? Nope, nothing is being added or subtracted to our variable term, so that can be skipped as well. Multiplication or division? Ah, there we go. We have a 5 being multiplied by our Q. Because remember, one of the ways we can show multiplication is if we have a number and a variable and they're side by side, that means they're being multiplied together. Now that I'm trying to isolate that Q, now that I'm going to be crossing over to the other side of the equation, we need to do the inverse. We need to do the opposite. So the inverse, the opposite of multiplication is division. Divide both sides by 5. 5 divided by 5 is 1, so it cancels out and we're just left with a Q. 15 divided by 5 is 3. And there we go. Our steps are all finished. Our variable is isolated, so we're good to go. Ooh, look at this one. We got lots of K's here, lots of K's. We have 7K minus 3K minus 4K plus 4K plus K equals 20. Whew, that's a lot. All right, do I need to distribute? Nope, doesn't look like in this practice today we're going to have a lot of distributing, but we do have a lot of like terms. All right, here's one nice thing. If you remember your guys' properties, whenever you have all multiplication and division, or all multiplication, or whenever you're in a situation like this and you have all addition or subtraction, you can add and subtract in any order. We can kind of group them up to make it a little bit faster. All right, so this grouping, what would be 7K minus 3K? That would be 4K. How about this grouping? What would be negative 4K plus 4K? That would be 0K. And then I just have a single K at the end. And hey, what does that 0k look like? It looks like okay. It's kind of funny. All right, but if it's a 0k, did I really need to write it? Nah. Which means we are left with 4k plus k. Ooh, what's that? That would be 5k. Because whenever we have a variable all by itself, there technically is an invisible 1 right there. Because whenever mathematicians are a little lazy, so whenever they're able to not write something, they don't write it. So because there's just a single k there, they expect you to know that that means there's one of them, because you see a k there, so there is one single k, meaning there's an invisible 1 right there. So 4k plus 1k is 5k. 5k equals 20. All right, we combined our like terms. Whew. Do I need to move the variable? Nope, no need to move it. How about adding or subtracting? Nope, nothing is being added or subtracted to our variable term. Multiply or divide? Bingo. We have multiplication going on. So what's the inverse of multiplication? Division. We're going to divide both sides by 5. 5 divided by 5 is 1. We're left with a 1k. What's 20 divided by 5? 4. All right, let's go ahead and try one more problem. Let's jump up a level here. All right, and it looks like when we jump up that level, we're going to get some positive and negative numbers. All right, this will be our final one. So let's rewrite it out here. 12a minus 16a equals a negative 8. Do we need to distribute? Nope. How about combine like terms? Yes, sirree. I got 2 like terms on the same side, which means I just do what it says. Well, it would be 12a minus 16a. All right, this would be a good time for us to go over our properties of integers. When we're adding and subtracting integers, if you notice that you have a subtraction sign, you can use keep, change, change to make it a plus the opposite. So essentially we can take that subtraction and rewrite it so we're adding the opposite. So we keep the first number the same, that stays a positive 12a. We change our subtraction sign to addition, and then we change our second number to its opposite. So it was a positive 16, now it becomes a negative. Once that subtraction is turned into an addition sign, we have 2 different rules for adding integers. The first rule is if you add integers and they have the same sign, you add them and keep the sign. So when you're adding, 2 positives result in a positive. 2 negatives equal a negative. But if you notice you have different signs, you're going to subtract them. Then look at the absolute value, so the positive version of your numbers, and whichever number is larger is the sign you're going to keep. That happens to be our case here. We have a positive 12a and a negative 16a. So they have different signs, which means we're going to subtract. 16 minus 12 is 4. But then we're going to look at the absolute value, so the positive version of our numbers, so 12 and 16. Which one's larger? 16 is larger. That means whatever sign the 16 has is the sign our answer has. Well, the 16 was negative, which means our answer is a negative 4a. All right, let's work our way through the steps. Do we need to move the variable? Nope, I don't have a variable on both sides. How about adding or subtracting? Nope, nothing being added or subtracted to the 4a, because even though we see that minus sign or that negative sign, that belongs to your 4. It's not A minus 4. It's negative 4 times A, which means multiplication and division is what we got going on. What's the inverse of multiplication? Division. We're going to divide both sides by negative 4. All right, here's a good time to talk about our integer rules for multiplication and division. These rules, in my opinion, are a little bit easier to remember, but they're different from the adding and subtracting rules. So you might accidentally get them mixed up. So that's where you got to be careful, is to not mix them up. Because in multiplication and division, if your numbers have the same sign, your answer will always be positive. So a positive times a positive is a positive. A negative times a negative is a positive. Then if they have different signs, your answer will always be negative. So for multiplication and division, same sign, your answer will be positive. Different signs, your answer will be negative. So here we have the same sign. A negative 4 divided by a negative 4 would be a positive 1. So we're left with just a single A. Negative 8 divided by negative 4 would be a positive 2. So you guys will definitely want to watch your negatives on this. Now, I do encourage you all to initially solve this and work all this out in your head or on paper without a calculator. But if you're feeling a little unsure, you can use the calculator to double check your work. Like for example, I would, do 12 plus negative 16. And then once you get that negative 4, type it in your calculator real quick and make sure that you're correct, because you really don't want to mess up your signs, because obviously it'll hurt your SMART score. So by you trying on your own, that'll help you practice and learn. But then by double checking with a calculator, that will help you not make mistakes and get frustrated on this IXL assignment. So it's kind of like you're self-grading your work. All right. So good luck, guys. You got this. Remember those positives and negatives. Ooh, I said good luck, but this one looks a little bit different. So I know it's going to make this video a little lengthy, but actually I changed my mind. We're going to do this one real super duper quick. All right. We have negative 9 plus 19n minus 17 equals 13. That's a really ugly 9. Let's fix that. Okay. All right, I copied down my problem correctly. All right, let's try this one out. First step, do we need to distribute? Nope, don't see any parentheses. How about combining like terms? Yeah, now what are my like terms in this case? The negative 9n and the positive 19n. Why is the negative 17 not considered a like term? Because it doesn't have the variable n. That is a constant. That is just a plain number. So we're only going to combine the like terms, which is our negative 9n and our positive 19. Right here, we have opposite signs. So we're going to subtract. 19 minus 9 is 10. Then we're going to look at the absolute value of our numbers. So a 9 and a 19. Which one's larger? 19. So that's the sign we're going to keep. The 19 was positive, which means our answer is a positive 10n. And then everything else is going to be copied down, because I didn't have any other like terms, because the 17 and the 13 are on opposite sides of that equation. They're not in the same room. They're not together. Do we need to move the variable? Nope. I don't have a variable on both sides. No need to move them. Skip that step. How about adding or subtracting? Yes, this is why I wanted to do this one, because this is our first one that we need to do adding or subtracting. We have 17 is being subtracted from our variable term. 17 is being subtracted from our 10n. So we do need to deal with that. What's the inverse of a minus 17? Adding 17. We will add 17 to both sides. Nothing changed with the 10 in, so just bring them on down. Negative 17 plus 17 is 0. That cancels out. 13 plus 17, 30. And we are on to our final step. Multiply or divide. Yep, I have multiplication going on. I have 10 times in. The inverse of multiplication is division. We'll divide both sides by 10. 10 divided by 10 is 1. We're left with a 1 in. 30 divided by 10 is 3. Bingo. All right, there we go. Now we've done our last problem. So as you guys are working on this, if you have any questions, just send me an email or make sure you come to help sessions. That way we can work on it together. All right, bye.